Hey, yo, what's going on, everybody? My name is John Radasta. I'm a Google Cloud architect and artificial intelligence engineer. I'm currently with Accenture Federal Services on assignment for the United States Department of Energy. But I want to do a quick informal video just about a fun project that I've been working on in the months before I was with Wayfair and with Accenture Federal. Just as a kind of intro as to like, okay, what goes into artificial intelligence? How does it work? What can and can't you predict with artificial intelligence? And what can, if we can't predict something, what does the data science process show us um, about our data, and how can we derive analytics out of it, even if we don't have a reliable predictive model? So back in February, I actually passed the TensorFlow Developer Certificate. So it's a 5-hour coding test given by Google. You have to develop 5 different TensorFlow models, machine learning models, ranging from computer vision, natural language processing, artificial neural networks, all that stuff. And you have to have a 90% or better on all of your models in terms of accuracy. So, but one of the things is, I was happy to get it. It was a great test. If you pass it, you more than well deserve the tens being considering calling yourself a professional AI engineer. But coming out of that, I have to be honest, I didn't feel like if you threw an AI problem at me at the time, I would have been like, soup to nuts. Would I be able to gather the data, clean it, run some AI, build a model, and derive some predictive insight out of it? I just didn't feel like I was comfortable enough to do that. So I wanted to take on what I considered my own sort of doctoral thesis for AI after, I, sort of passed this sort of master certificate, right? And one of the things is, okay, I want to take a full-fledged ML problem from soup to nuts. I have no data, okay? I just have a theory that I want to test. And I want to see if I can get some data, clean it, derive some insights out of it, visualize it, predict something out of it, and potentially maybe even profit from it, right? Because, there's a lot of, obviously buzz around AI, and there's a lot of cool stuff that AI can do. Hey, if we can make some money while we're doing it, great. Why not, right? So one of the things was, okay, I have this process. I have a journey of something that I'm going to learn along the way, either way. So either way, I win. Okay. But maybe I can benefit out of this too. So I came across stuff like this, right? So, okay, elderly mathematician hacked the lottery for 26 million. Well, that would be great if we could do that. And I was thinking, I'm like, if a mathematician can crack the lottery using just a pen and a notepad, drawing on a notepad, well, surely we can crack the lottery with AI, right? I mean, AI is a lot smarter than people. That would make sense, right? AI can go over all sorts of stuff that people can't see in terms of dimensionality and features, right? So it actually turns out this guy was cracked the lottery in a little different way. He wasn't. He actually did what was called the roll down hack. So a roll down hack was done actually originally out of a group out of Boston with MIT that certain lotteries have what's called a roll down, so that if people don't hit the jackpot keeps growing like every other lottery, but every like fourth or fifth week they have what's called a roll down. Okay, and the roll down basically says that, okay, if nobody hits it on week 5 or 6, we're going to liquidate the jackpot among the top 5,000 winners, right? And like the amount of each prize rolls down to all the winners based on how many numbers you hit, right? So his little hack actually is, based on, believe it or not, pretty simple mathematics. It's just, you're just calculating the expected value of the lottery ticket. So if you do the math, basically, I think I looked at it. The expected value of a lottery ticket is like negative 50 cents. So for every dollar you spend, you lose 50 cents. But on a roll down week, what these mathematicians or the people at MIT calculated is that the expected value of a lottery ticket actually goes up to like $1.65 if you play them in mass on a roll down week. So you have a net positive expected value. So you can just buy as many tickets as you want, and over the larger number of tickets, you will be profitable. So this is a little bit of a different hack, but I want to see if there was actually any other type of hack that we can tease out of the lottery. Maybe there's some sort of algorithm that the lottery is using that we could basically crack that algorithm using AI. So I needed to find data, I needed to clean it, and then I needed to visualize it before we could predict it. So luckily, all the lottery websites out there, they have a lot of great data out there. So Florida Lottery was great with it. All the winning numbers are on here. And I thought was pretty cool is they provided the winning number history in HTML format. So you can go through here and you can see all the winning numbers all the way back to, like, in this case, 2013. But they have some, like the Powerball, I think, goes back to like 1991 or something like that. So it's a ton of data. But the problem is that you can't just feed this website into a machine learning model, because this is what we call unstructured data. So unstructured in the sense of, like, okay, well, what does this mean? Okay, well, we know it as a date. Okay, we know that's a date format, but a machine learning model isn't going to know that out of the gate. And MB22, well, most people probably don't even know what that means. That's the mega ball, right? That's like the bonus ball. But again, a machine learning model has no context of that. There's no schema that says that's what that is. And similarly, what this is a multiplier. There's no context around it. So this is like typical of what an enterprise corporation will run across, that, okay, we want to get into AI, we want to predict stuff with our data. 99% of the data that a company is going to have, especially bigger, older legacy companies, they're going to have data like this, where it's like, some of it looks like this and some of it looks like this. And it's just all kind of like different structures or unstructured completely. So you have to make some sense out of it first. So I knew I had a great data set here, but I needed to put some structure around it. So I built a little program that I call the Florida Lottery Scraper. Okay. I built it in Go. And basically what you can do is you can put in any of the Florida Lottery winning number websites here. Okay. And you can put in the type, whichever game you want to get data from, specify the name of the file, and then it'll go out and just grab these HTML tables and these rows and just basically put them into CSV format. CSV format is basically Microsoft Excel's raw format. So comma separated values, just like you'd see in an Excel workbook if you wanted to export it. So what I'm going to do is I'm going to delete this just so you can see how this runs here. So I have a folder called data. I'm going to run this scraper, and the scraper is going to go out and get all the data and kind of process it into a nice structured format that we can go in and further clean and stuff using some data science. So I'm going to run go main.go. Okay. As you can see, here's my user agent. So I have an HTTP client that reached out. And then if I go back here, here's my CSV file here with all the winning numbers going back to 2013. So the only thing is I don't have column names on this. So I'm just going to quickly, before we go into the data science aspect, I'm going to label these columns. So again, comma separated values. So date, number 1, number 2, number 3. These are ball numbers. So ball 4, ball 5, ball 6. And then we had, well, the money ball was ball 6, and then this is going to be mult. So it just, in the data science notebook I have, I call the money ball 6 because it's different depending on the game. Powerball versus Mega Millions and stuff, they all have 6. So I'm going to save that. Okay, so now I have nice, clean, structured data that is almost ready to go into a machine learning model. So these are essentially going to be fed into a machine learning model as vectors, which is basically what it looks like. And then hopefully we can get some predictive value out of it. So now I'm going to go into my terminal here, and I'm going to cd into notebooks. Okay, so here's all of my Jupyter notebooks, my data science stuff. So Jupyter notebook, into the directory, start the Jupyter notebook server, and here we go. So first things first, before we get into some of the finished TensorFlow models that I built for this to see if we can get some predictive insight, the first thing we have to do is we have to look at this data, we have to visualize it, and we have to see if there's anything that we can tease out of it, like if there's outliers, or if there's some unstructured primitive types in there, or primitive types that we can't use, or missing values, or something like that. We have to treat all of that data and really kind of massage the data before we feed it into a machine learning model even further. So Things like dropping unnecessary columns, looking for missing data types, correct types, all that stuff. We're going to do that. So this is already done. I'm just going to run the notebook here, and we'll see some of the visualizations that we've gotten here. So, and I'll kind of go through them. So first and foremost, here's our data as a data frame here. I'm going to drop the mult column because the multiplier really doesn't affect predictability. We're not trying to predict what the multiplier is going to be. Who cares? Let's just get 6 numbers and then we win, right? So name of the 6th column, again, doesn't matter. Let's see. So now we have a nice clean data frame. Here's the tail. Now the first thing we're going to do is we're going to check if there's any missing data types. Okay, so luckily it doesn't look like there's any missing data types, but let's do a visualization on that. Here's basically all of the data. If we do have missing values here, we'll see little white lines, horizontal lines going across, but we don't have any, so it doesn't look like we have any missing data, which is cool. Pretty clean set. So this is all of the winning numbers going back to 2013 visualized. So as you can see, the lottery is pretty random, right? So the blue here is ball 1. Looks like the yellow here is ball 2, etc., etc., green, red, purple. Okay, so if it looks like a big mess, it's because it is, and there is an element of randomness to the lottery. But what these visualizations, I learned from these visualizations, is there actually is a little bit of order to the lottery, and there's some stuff that we can tease out of this. So when we look at it like this, it looks like a big jumbled mess, right? But if we look at each ball individually, we're going to see a pattern emerge. Watch this. So first we're just going to visualize just ball 1, okay? So here's ball 1, okay? Before I say anything, let's look at ball 2. Okay? Now here's ball 3. Ball 4. Ball 5, and then the 6th ball, which is the money ball. Right? Oh, 6th column. This is the money ball. So here's the interesting thing. What do you notice about this? What I noticed is that, well, look at this. We have clustering around a certain range. So ball 1 tends to cluster between 0 and 20. Okay. Ball 2 tends to cluster between 10 and 30. What ball is this? Ball 3 is between 20 and it looks like around 45 or something like that. So we're starting to see a pattern emerge. This is a histogram just showing how many occurrences of each ball from 0 to 70 each ball came up as. So it looks like ball 3, for the most part, the most occurrences was around 30 or 31 came up for ball 3. So we know that, okay, we're getting clustering for each one of these balls, which is interesting. You would never think that. If the lottery is completely random, why are we getting clustering around here? So if we look into this a little bit further, this is what the interesting thing we show. If we look at the mean and stuff, this is what ball 1 looks like. So I just plotted this in terms of like the mean versus like the standard deviation, 2 standard deviations, right? So this is for ball 1, this is the mean. The mean is around 11, okay? But the standard deviation, okay, is it 2 standard deviations I did? How many standard deviations did I do here? It looks like I just did 1 standard deviation. So this is 1 standard deviation above. So what this means is that 68% of all the occurrences for ball 3 will happen between the black lines here. That's basically what standard deviation means. So 1 standard deviation above and 1 standard deviation below basically means that about 68% of all the occurrences for this ball will happen between these black lines. So that actually kind of closes it down. You see a little bit of a strategy emerging here. The first ball that you pick probably shouldn't be a 70 or a 60, whatever the topmost number is for the Mega Millions. It should be something between 0 and 20, right? And same thing for the second ball. Your second ball should be something between 11 and say 34 or something like that, with the mean being around like 22, all right? So again, we have some occurrences out here, but the majority of the occurrences is happening between these black lines, right? Same thing for, what is this? This is ball 3, okay? Same thing. We're getting clustering around 22.